Definition of continuous. This line is too thick. Okay, definition of continuous. Now, first thing, you have a 3 requirement. That simple test question I would tell you, like this on the test, I would just ask you what's definition to being continuous. The first one, it says FA must be defined. Must be defined. Now, on AP exam, they really emphasize on definition and theorems. This is one of the most common questions. It didn't matter what A, B, or B, C. Everybody had to go through this. Definition continuous. You just have to memorize this, but best to understand it. So I'm going to say it's understand it first. So let's just say if I have, what does that mean? F of A must be defined. So let's just say if I have A here, and this is 1, and this is 2, and A must be defined. It just means that there is a closed circle over there. And I have finished my A is defined. Now, the second one is limits x approach to A of fx must exist. So what I mean by that is this. It means limit x approach to A from the left of f of x equal to limits x approach to A from the positive side of f of x. Because they must reach the same common point. But then you say, is that means continuous? No, because you can possibly have something like this. You have like this, right? Is this function continuous?
No.
No. Imagine you have a roller coaster and you have a hole there. That's not the one you want to ride at least, right? So then we gotta make at least functional roller coaster. What does it mean function? And luckily I have this apps. This apps is really helpful for this. So the last one is as the limits as x approach to A of f of x must equal to f of A. That means 1 and 2 must equal to each other. Why? Imagine this, if I x approach A, so in this particular case right now, that I'm gonna have limits as x approach to A from the left of f of x is equal to 2, right? Limits x approach to A of f of x equal to 2. Huh? Oh, sorry. I don't know how to make smaller here. Yeah, anyway. So right now, as limits x approach to A from the left of f of x is equal to 2. And limit x approach to A from the right is f of x equal to 2. Now they exist, but they don't have the same value because f of A is actually 1. So this right now, it says limit x approach to A of f of x is equal to 2. So it exists, but it's not equal to 1. So what does equal to 1 mean? That means I can take this, I can say, hey, let's move downwards. Now I'm no longer discontinuous. I'm actually continuous. Does that make sense? And that's it. Continuous now. And now you fulfill the definition of continuous. Those 3 requirements, you have to understand visually how things work, because they love ask word question about definitions. And if you don't know it, you're not going to survive in the AP exam. If you know it, those are 3 points. 3 points. Now let's talk about discontinuity. Okay, if you have some type of discontinuity, there's 2 types. The first type is called removable discontinuity. The second type is called non-removable discontinuity. So discontinuity, the first one is called a hole. You guys probably know as a hole. Second one, there was two type. There is a jump, which is usually occur with greatest integer function. And the B is going to be a vertical asymptote. So there are a hole and greatest integer function or absolute value function. Absolute value. Rational expression, but there was some absolute value equation. So greatest integer function. Sorry, integer is spelled wrong. Greatest integer function. You guys never seen that before, but it's okay. We'll probably introduce you to tomorrow. We have more time. And there is a jump, right? Now, let's just say f of x equal to x minus 4 over x squared minus 16. How do I find removable discontinuity and non-removable discontinuity? How do I find them? Well, how do I find them? How do I find removable discontinuity? How do I find a hole in algebra pre-calculus? How do I find a hole? Nobody remember?
Roll the ball.
No? It's a factor. Oh, I'm sorry. This is a negative 4. You factor the top and you factor the bottom. Now, whatever you can cancel the factor, which is we do it all the time recently, whatever the cancel factor is going to give you the whole, which is cancel factor. Now, the whole is a coordinate, right? Its whole has a coordinate. Then what you're going to do is 1 over x plus 4. If you simplify that, that's 1 over x plus 4. Now, where's the whole at? Well, you take the cancel factor like this, and you set it equal to 0, and you solve for it. You got an x coordinate of the whole. Am I going too fast? Then all I'm going to do is plug this 4 in here, and then that's going to give you 1 over 4 plus 4. That's equal to 1 over 8. And then that's going to be 4 comma 1 over 8. That is your removable discontinuity. That's a removable discontinuity. So whatever you cancel factor, that's going to give you a whole. And you set that equal to 0, you get x value. You can plug it back in the modified equation. Then you get a location in that hole. You learned this in pre-cal, you just don't remember it. Wait, have you guys learned this pre-cal?
Yeah.
Cooper definitely for sure did. I don't know about Ollie. Did Ollie talk about it? No? No comment. Cooper is a good teacher. Now, I'm gonna set, now there's a new function, right? There was a vertical asymptote here. There's a vertical asymptote here. So vertical asymptote here, because after you cancel, there was a vertical asymptote. Vertical asymptote is denominator equal to 0. So it'd be x plus 4 equal to 0, x equal to negative 4. So at x equal to negative 4 is a non-removable discontinuity. Non-removable discontinuity, which is in this case is a vertical asymptote. Vertical asymptote. So if you have vertical asymptote, it probably looks like this. I'm gonna attempt to graph it. At -4, it's gonna asymptote like this, and the graph is gonna be the fourth quadrant, and like this, and this coordinate is gonna be 4, and that's gonna be 4 and 1/8, and that's what the graph is gonna be like. I'll see you guys tomorrow.